Here is a small card with an arrow pointing to the right and a red dot up in its corner. Now I turn the card a quarter turn clockwise. Without touching a thing, where does that arrow point? Watch it happen. A quarter turn clockwise, and the arrow that pointed right now points straight down. The dot rides around with it. That single move, turning a shape in your mind, is the heart of spatial reasoning. Over this lesson, we'll master every kind of these puzzles: rotations, mirror images, folded paper with punched holes, cubes built from flat nets, and patterns that ask what comes next. And the golden rule throughout is simple: don't chase the whole figure. Follow one clear feature. The options in these puzzles are designed to look almost identical, so staring at the whole shape just tires your eyes. Take this card: an arrow, a corner dot, a little notch. Too much to track at once. So pick just one distinguishing feature, say the red dot, and lock your attention onto it. Ignore everything else. Now apply the move to that one feature. Turn the card or flip it and just ask where the dot lands. Once you know that, the whole answer is settled. One feature does the work of the entire figure. Start with rotation, turning a shape around a fixed point, its size never changing. Almost every rotation question rides on one little cycle. Take an arrow pointing right and turn it clockwise, a quarter turn at a time. A quarter turn clockwise sends right to down. Another sends down to left, then left to up, and up back to right. Right down, left, up. That loop is the entire trick for a clockwise turn. Anti-clockwise just runs the same loop backwards. Right to up to left, and so on. And a half turn, 180 degrees either way, simply swaps each direction with its opposite. Right with left, up with down. Let's rotate a real shape. Here is a bold letter F, asymmetric, so there's no hiding. Turn it 90 degrees clockwise. Its upright stem should swing over to lie along the top, arms hanging to the right. And there it is. The stem now runs across the top. The two arms drop down the right side. Notice the shape is unchanged in size, only its orientation turned. That is rotation and nothing else. Second example, a half turn. This card's arrow points up with the dot at the top right corner. 180 degrees flips everything to its opposite. The arrow will point down and the dot will land at the bottom left. Turn it, and both predictions come true. Arrow down, dot at the bottom left. When you're unsure of a rotation, half a turn is the friendliest of all. Just read off every opposite. One more, and it hides a shortcut. Rotate this F 270 degrees clockwise. 3/4 turns is a lot to picture. So flip the problem. 270 clockwise is exactly 90 the other way, anti-clockwise. So just turn it a single quarter turn anti-clockwise. The stem sweeps to the top, arms reaching left. Always trade a big clockwise. Turn for the small anti-clockwise. One, far less to hold in your head. Here is the single most important idea in these puzzles, and it trips up almost everyone. Rotation and reflection are not the same move, and no amount of turning will ever undo a flip. Take our F on the left. Reflect it across this vertical line, and the copy on the right is its mirror. A back-to-front F. To your eye, it's clearly a different shape, flipped in handedness. Now the proof. I'll spin the original F all the way around, a full turn, every angle it can possibly take. Keep your eye on whether it ever matches the mirror copy. It came back exactly where it began, and at no angle did it become the mirror. That's the tell. If a shape looks flipped, back to front, it's a reflection. If it only looks turned, it's a rotation. Reflection reverses the order of things. Rotation preserves it. Reflections come into flavors, set by where the mirror stands. A vertical mirror, standing up like a doorway, swaps left and right while top and bottom stay put. A horizontal mirror Lying flat like the surface of still water does the reverse. It swaps top and bottom and leaves left and right alone. That flat water version even has its own name, the water image. The favorite mirror puzzle is a clock, and it has a beautifully clean rule. When you see a clock in a vertical mirror, the reflected time is simply 12 minus the real time. Take 312. 12 minus 3 is 9, so its mirror reads 9 o'clock. Watch the real clock on the left and its reflection on the right. The hands swing to the mirrored side, and it truly says 9. 420. 12 minus 420. Borrow, and you get 740. 150 mirrors to 1010. A quick way to check. The two times always add back up to 12, and 815 reflects to 345. Same rule every time. 12 minus the clock. A different challenge now. The hidden figure. You're given a simple shape and a busy design and asked, is the simple shape buried somewhere inside? The trick is to hunt for its exact edges, ignoring every extra line. Here is the busy design. A little house, crossed with extra diagonals and a line down the middle. Somewhere in that tangle sits our triangle. Your eye wants to give up. Don't trace the three sides you need. There it is. The roof. Its two slopes and the line across the top are exactly our triangle, brightened out of the clutter. The rest was just noise laid over it. Match the edges, not the whole picture, and hidden figures fall out. One more, quicker. Find a square inside this overlapping design. Two rectangles crossing leave a small square right where they overlap in the middle. See it light up. Same method. Look for the target's own borders. Now the folded paper puzzle, a favorite, because it looks impossible and is really just counting. You fold a sheet, punch a single hole through the folded stack, then unfold. How many holes appear and where? Every fold doubles the layers. No folds, one layer. One fold, two. Two folds, four. Three folds, eight. So a single punch through all the layers makes exactly that many holes. 2 to the number of folds. Let's do a full one. Here's a square sheet. First fold, bring the right half over onto the left, along the middle. Watch the sheet halve in width. That is 2 layers now. Second fold, bring the top half down onto the bottom. The sheet becomes a small square, 1/4 the size, and 4 layers thick. Now punch a hole near the inner corner. The corner where both creases meet, which was the very center of the original sheet. That one punch drives through all 4 layers at once. Now unfold, one crease at a time. And here is the golden rule. Each hole mirrors across the crease you open. Undo the horizontal fold first. The top half swings back up, and the hole reflects upward into it. One hole becomes 2. Then undo the vertical fold. The right half swings out, and both holes reflect across the center line into it. 2 holes become 4, perfectly symmetric about the middle. And there is the answer, 4 holes, one in each quarter of the sheet, sitting symmetrically around the center. 4 layers, 4 holes. The counting and the picture agree exactly. Cutting works on the very same principle as punching, just with a shape instead of a dot. Fold the paper, snip a notch out of the folded edge, unfold, and the notch appears mirrored. Once for every layer. Fold this square once down the middle, so the left half lands on the right. Then cut a triangular notch out of the folded edge, the crease side, unfold it. That single notch on the crease opens out into a full diamond-shaped hole, sitting right on the center line. The two halves of the cut are mirror images meeting at the fold. Cut on a fold, and you always get a shape symmetric about that crease. Cube puzzles give you a flat net, 6 squares joined at their edges, and ask which cube it folds into, or which faces end up opposite. Here is the most common net, the plus or cross shape. Its 6 faces colored and labeled. Two rules unlock everything. Faces that share an edge on the net end up next to each other on the cube, always adjacent, so they can never be opposite. And to find a face's opposite, count 2 steps along a straight strip. Let's actually fold it. Picture the center face flat on the table, and the 4 faces around it swinging up, plus the far one folding over the top. The flat cross closes into a solid cube. Turn the finished cube in space, and you can read the pairs straight off. The green front sits opposite the far back face, left opposite right, and top opposite bottom. 3 clean pairs. That's the whole answer. The special case worth memorizing is a standard die. Its opposite faces always add up to 7. So 1 faces 6, 2 faces 5, and 3 faces 4. If a puzzle shows a die with a 1 next to a 6, it cannot be a standard die. Those two are opposite, never neighbors. The last family asks, given a row of figures that change step by step, what comes next? The move is to name the rule connecting one frame to the next. A turn, a growth, a shift. Then apply it one more time. First series. A bar with a red tip, turning 45 degrees clockwise each step. Upright, then tilted, then flat to the side. Every frame is one more quarter of a quarter turn. Each step adds 45 degrees. So the next one is another 45 on from the last, landing at a full half turn. The tip now pointing straight down. Draw it in the empty box, and the pattern completes itself. Second series, a growing one. Boxes holding one dot, then 2, 3, 4. The count climbs by 1 each time. Some patterns are about turning. This one is about counting. 1, 2, 3, 4. So the next box holds 5 dots. Count the change, add one more step, and you have it. Whether the rule is a rotation or a count, the method never changes. Your turn, pause whenever you like. This card's arrow points up, dot at the top left. Turn it 90 degrees clockwise. Where do the arrow and the dot end up? Picture it before I show you. Clockwise sends up to the right, so the arrow points right. And the top left corner swings round to the top right, carrying the dot with it. Arrow right, dot top right. To settle it. First, a sheet folded 3 times, then a single punch. How many holes? Second, a clock reads 7 o'clock. What time does its mirror show? Pause and answer both. 3 folds make 2 to the 3 8 layers, so 8 holes. And a clock's mirror is 12 minus the time. 12 minus 7 is 5, so it reads 5. If you got 8 holes and 5, you've genuinely mastered this. Trap 1. The big one. Mistaking a mirror image for a rotation. If a shape is back to front, no turn will fix it. When you see a flip, think reflection, not rotation. Trap 2. Miscounting folded layers. Every fold doubles them. 2 to the number of folds. Adding or doubling just once gives the wrong whole count. Trap 3. On a cube, 2 faces that touch on the net are neighbors, so they can never be the opposite pair. Opposite faces are the ones that don't share an edge. Trap 4. The clock rule. A vertical mirror gives 12 minus the time, every single time. Don't guess it, compute it. And trap 5. Never commit to the first answer that looks close. Scan all the options and rule out any with the wrong turn direction, the wrong mirror side, or the wrong whole count. Let's gather the whole toolkit. Rotation. Write the cycle. Right, down, left, up. And always swap a big clockwise. Turn for the small anti-clockwise one. Rotation versus mirror. If the handedness is flipped, back to front, it's a reflection, and no turn will ever reach it. Mirrors and clocks. A vertical mirror swaps left and right, and a clock reflects to 12 minus the time. Hidden figures. Trace the target shape's own edges and let the surrounding clutter fall away. Folded paper. Layers are 2 to the number of folds, and every hole mirrors across each crease as you unfold. Cube nets. Faces that touch are adjacent, faces to apart along a strip are opposite, and a standard dies opposite faces sum to 7. And figure all series. Name the rule, a turn or a count, and take one more step. Through every one of these, the same habit wins. Follow one clear feature and let it lead you to the answer.